right, I'm back. Number 15 of the review. Halfway there. So I already wrote down the question. And with the information given, can you do these two things? So first thing you're asked to do is the product rule at t equals 3. So the product rule is, and you can see the first and the second, is the first times the derivative of the second plus the second times the derivative of the first. Next, because we're doing it at 3, we're going to put 3 in wherever there's a t, and then just plug in the information. So in this question, r at 3 is negative 2. S prime at 3 is 5 plus S at 3 is negative 2. And then R prime at 3 is 3. And there it is. So it's negative 10 subtract 6. So you get the answer negative 16. All right, part B, I think is a quotient rule. Let's see. Sure I got it. Got it. Oh, there's even a part C. So here we go. So part B is the find the derivative with respect to st. So we have r, or with respect to time, I mean, we have rt divided by s at t, again at 3. So let's figure this out. So we're going to make this short because we're going to plug in 3 wherever there's a t right away. So the quotient rule, nice healthy fraction line, is the bottom. Instead of t, I'm going to put 3 in right away. So the bottom times the derivative of the top. Again, every time there's a t, I'm just going to put 3 in right away to save a little time. Subtract the top times the derivative of the bottom. And then the bottom squared. Now substitute in what you know. So s at 3 is 2. R prime at 3 is 3. R at 3 is negative 2. S prime at 3 is 5. And then again, S at 3 is 2. And you need to square it. So there's the setup using those values right from the question. And now let's finish it. So 2 times 3 is 6. A negative times a negative is positive. So it's 6 plus 10. And then 2 squared is 4. So I'm just going to leave, well, 16 divided by 4, I can definitely simplify that. So it's 4. Part C. This is the either chain rule or the general power rule. But you see the chain, the inside we have a composite. So how do we take the derivative of that? And again, this is when t equals 3. So it's the derivative of the outside, and again I'm going to plug 3 in right away, times the derivative of the inside. So this might take a couple steps. So inside the derivative, s at 3, that is 2. S prime at 3 is 5. One more step. R prime at 2, that's 4. Again, all these values are given in the question. And then 4 times 5 is 20. Done. All right, on to 16. 16 has a bunch of parts. Great. X at t, that's the position of a function of a particle moving horizontally, left to right. So there is there's the position function. So part A says, find the velocity. So how do you find the velocity when you have the position? Just take the derivative. Here we go, 3 times 2, that's 6t. Subtract 1 from the exponent. 2 times negative 3, that's negative 6t. And then the derivative of 2 is 0. Part B says, find the acceleration of it. So the acceleration is the derivative of the velocity. So that's 12t minus 6. So 2 times 6 is 12, subtract 1. Negative 6t is negative 6. So the derivative and then the derivative again. Part C, when is the particle at rest? So now we have to think, which of these equations do I use for what's being asked? So for rest, that has to do with direction of the particle. And that has to do with movement of the particle. That has to do with velocity. So if we take the velocity equal to 0, it will tell me when it is at rest. So I take the velocity equal to 0, solve this by factoring out a 6t. That leaves me a t minus 1. So then when I solve it, the first answer, 6t, gives me the answer 0, and the second one gives me the answer positive 1. Make sure we're all on the right track here. Part D. Part D says, when is the particle moving left? So again, direction movement has to do with velocity. So left means when the velocity is negative. So what I'm looking for is when that is occurring. So how do I know that? Is I'm going to draw a number line, and I'm looking to see first when is it at rest, and then I create intervals from resting to know if it's negative or positive. So we just found out that 0 and 1 is when it's at rest. So we have 3 intervals to test into the velocity. So, and I can do right here into the factored form because it'll be easier. So if I plug in any negative number, negative 1, a negative times 6, that's a negative, and then a negative subtract 1 is still negative, so it's a negative times a negative. And if you follow that, all I care about is the sign, if we can follow that numerically. So it's a positive sign. So what does that mean? From negative infinity to 0, which direction is it moving? It's going to the right. From 0 to 1, what number? Well, let's say we pick 1/2. So 6 times a half, that's positive. A half take away 1 is now negative. So a positive times a negative, that's negative. Pick any number bigger than 1, like 1 billion, put it in. You can clearly see that that velocity is positive. So the question again is, when is this moving left? So the answer is between 0 and 1. And then on an AP exam, you give your reason. Why are you saying it's moving left? Because the velocity is less than 0, or the velocity is negative. E. When is the particle's velocity equal to 12 feet per second? So take the velocity, make it equal to 12. So that's what I'm going to do. This is a quadratic, so I'm going to subtract 12 and make it equal to 0. I'm also going to simplify this. So I'm going to divide everything by 6. So if I divide everything by 6, I get t squared subtract t subtract 2. And then I can factor it. So hopefully it's easy factoring, negative 2 and positive 1. So then when I solve it, I get positive 2 and negative 1. So when is the velocity equal to 12? And the answer is 2 when t equals 2 and negative 1. Where are we at? F. We're almost there. F, G, and H. F, find the particle's speed when the acceleration is equal to 0. So step 1 is when the acceleration is equal to 0. So I need to take the acceleration and make it equal to 0 and solve it. So I take the acceleration equal to 0 and I'm going to solve it. I'm going to add 6 and divide by 12. So when I divide by 12, it's going to be easier to use 1/2. Next, we're going to plug that into the velocity. Now, speed is the absolute value of velocity. So we're going to go absolute value, and we're going to plug 1/2 in using the absolute value bars. So a negative answer we're going to write as a positive answer. So velocity, there it is. It's 6, and it's 1/2 squared. Subtract 6 times 1/2. So let's start. So 1/2 squared is a quarter. Half of 6 is 3. So I have 6 times a quarter. I'm not going to overthink it. That's 6 over 4. 3, I'm going to write with the same denominator 4. So I'm going to write that as 12 over 4. And then 6 take away 12 is negative 6 over 4. Now we know we have absolute value bars, so we're going to write it as a positive answer. I don't have any units to write with this. So I don't have meters per second or anything like that. So the answer is just 3 over 2. G. For part G, it asks us for the displacement. Now, the displacement between 1 and 3 is just the difference between where it ended. So it said 3. So this is the position. So what position of where it ended to the position from where it started. Oops. So that's it. So plug in 3 into the position, plug in -1 into that position, and then subtract it, and that is your displacement. So if I plug 3 in, it's 2 times 3 cubed, subtract 3 times 3 squared plus 2. And I'm going to subtract, use parentheses. I'm going to do the same thing, but with -1. And then solve it. Oops, I'm going to solve it down here. So part G, if you did it correctly, that answer would be 32. I'm okay if you just plugged it into a calculator. Actually, this is a good answer too, right? AP exam, you don't have to simplify it, so you don't have to write it all the way down to 32. H, last one in this group. Find the total distance. Now, total distance is different than displacement. Do you remember the difference? So, total distance, what it does is calculate the distance traveled to the right, the distance traveled to the left, and they treat all of those distances as positive numbers. And then you add up all the distances so you know all the distance it went. So to the right, to the left, to the right. Each time it changes direction, you find that distance and then add them all up. So look back here. Can you tell that first it's going to the right, then it's going to the left, and then to the right? Now we want it from -1 to 3, right? Yeah, so -1 to 3. So can you see where -1 is? So from -1 to 0, it's going to be to the right. So we're going to do that first. -1 to 0. So that means this is the setup from -1 to 0. And I know this answer is positive, but it's good habit to put absolute value bars around it. Plus, from 0 to 1, this one's going to be a negative answer. So those bars are essential. Plus, the last bit would be, again, we're going from -1 to 3, and whenever it changes direction, we have to chunk it into intervals. So the next interval chunked is 1, 2, 3. And there's your setup. Now this last one, because we did the math, I know this one and this one will be positives, so the bars don't do anything, but that middle one would have a negative answer, and those bars are essential. So you would plug those numbers into the position. So I'm going to do that for you, help you through it. So if you plug in 0, that's the easy one, you get 2. If you plug in -1, you get -3. I'm just looking off the answer key, kind of cheating. We're just going to split up like that. You can cheat with me. Oops, I already had a bar there. So it's 2, subtract -3. The next one, 1 and 0. So if I plug in 1, that was actually easy. 4 take away 3, that's 1. Plug in 0, we got 2. One more. Plug in 3, that was the bigger one. That's 29. Subtract. If you plug in 1, we just did, which is 1. So there's the setup. Substituting into the position equation. And then solve it. So subtract a negative. That's 5. So 2 plus 3. 1 take away 2 would be -1. Remember I said it is going to be negative, but the absolute value makes that +1. And then 29 take away 1 is 28. And then all together, I got room. All together, 5, 1, and 28. So that's 34. So what's the total distance that particle went? And the answer is 34. So what's the difference between total distance and displacement? So displacement, all that matters is where it ended and where it started. That's it. And subtract them. Total distance, we have to know how far it went to the left, how far to the right, how far to the left, and add them all up as positive distances. And to find the distance something went, you just plug in the end and plug in the beginning and just subtract. Nice and simple. Awesome. Number 17 requires a calculator, so I'm going to do that right now. This one is easy on our calculator, so we're going to make it easy. So the function is 4 to the x, subtract 3x. And the question is to find these certain things. So the derivative at 3, the second derivative at 1, and to graph the derivative, or have a sketch of it. And I'm just going to sketch it here on the side. So let's start with how simple this is to begin with. So here's my calculator. If I want to take the derivative of that, what am I going to do? So I'm going to press Menu. I'm going to go to Calculus. I'm going to go to Derivative at a point. So it asks for the variable, the value, and what derivative number it is. So this is going to be helpful for part B when it asks for the second derivative. I'm going to change that. Anyway, the variable is x. The value is at 3. And we do want to find the first derivative. So there's the setup to begin with. Then we actually type in 4 to the exponent x. Move the cursor, subtract 3x. And then Control Enter. And then I want you to notice that it's 3 numbers after the decimal. So for this one, it would be 85.722. Practice truncating. It's okay not to have to round. 3 numbers after the decimal. All right, let's practice it again. So the next one I want to do is I want to find the second derivative at 1. How would I do that? So I'm going to go to Menu. I'm going to go to Calculus. Derivative at a point, so number 2. The variable is x, and then the value is at 3, but no, sorry, at 3. It's at 1. And then for this one, let me go back again. Sorry. Let's try that again. I might have to use the cursor pad there. So Menu, Calculus, derivative at a point. The value's at 1. Oh, let me use the arrow. Cute. There it is. Go down 1. Press Enter. Now we got second derivative. So I used the arrow pad and clicked on that right arrow, brought down the menu, second derivative, Enter. Now we're styling. So 4 to the x. Move the cursor. Subtract 3x. Control Enter, 7.687. All right, last one we want to do and see the derivative graph of this. So to do that, we're going to press that toggle button. It has like a calculator with the wavy lines. Press it. Takes us to the graph. We're going to type in the derivative. So Menu, let's escape that. So instead of Menu, we're actually going to press the button to the right of 9. That brings it up. So to the right of 9, it brings up this menu. And then where it says derivative and it happens beyond it, press Enter. Oh, it's not derivative. Undo that. Silliness. So let's go back here again. So again, the button to the right of 9, my eyes are failing me. It's that button. There's the derivative button. The variable is x. It's 4 to the exponent x. Move the cursor. Subtract 3x, press Enter, and then see what does this graph look like. So we're going to sketch that. And I can see it approximately goes right before 1 and right after here. I'm just finding approximate intercepts, and I get a curve. And is that a good sketch of that? Hey, that looks pretty good, right? Good. Turn the page, 18. In number 18, you're given a function and asked to find the AROC and the IROC. Average rate of change is algebra. Now, before I start doing that, I'm going to change the way this looks. So this equation says, function says 4 over 3x squared. So I'm actually going to square it out, no parentheses. 3 squared is 9. And then I'm going to write that as 4/9 x to the negative 2 when I want to. So in other words, why would I write it this way is when I'm doing calculus. When I'm just doing algebra, I'm just going to leave it that way and not have x to the negative 2. So I'm going to use both forms. They're equal. But for calculus, I'm going to use the second one so I can do the power rule easily. So first of all, AROC. That means average rate of change. Sometimes it's called the difference quotient, the slope formula. y2 minus y1, x2 subtract x1. So what are our x's? It goes from 1 to 2. So our x's are 2 and 1. And then I plug those numbers in. So it's f at 2 subtract f at 1. So when I substitute in, first substitute in 2. Then substitute in 1. Now dividing by 1 doesn't change anything in the numerator, so that's good, right? So when I do this, notice that 2 squared is 4. Well, 4 divided by 4, that gives me 1/9. Isn't that neat to just be done like that? And again, divided by 1 doesn't change anything. So you see how the 4's divide out? Then 1 take away 4, you get negative 3/9 or negative 1/3. Perfect. That's your average rate of change. Your instantaneous rate of change, that's going to be the derivative. So we're going to use the second form. So the derivative is negative 2 times that. So negative 2 times that is negative 8. So I just need the numerator. So negative 2 times 4. So it's negative 8 over 9. Subtract 1 to the exponent. Then it says to plug in positive 1. And the good thing is, whenever you plug in positive 1 to any exponent, that answer is 1. So that just leaves you with negative 8/9. Done. Number 19. You're given a function y equals the square root of x, and you're asked to say that the y coordinate is increasing at the rate of 4 centimeters per second. So what they did is they gave you a rate. This is called a related rate. So it's the derivative with respect to time. So dy by dt is 4 centimeters per second. I'm asked to find the rate of change for x. So my goal is to find this. And in order to do the work I need to do, I need an x and a y coordinate. Well, it gives you the y coordinate is 2. Is that good enough to find the x coordinate so then I can start doing the work? So if y is 2, then what would x equal? So I just plugged in y is 2. What does x equal? Well, square both sides and you can see x equals 4. So we have y equals 2, x equals 4, and we're going to start here. Now I'm going to write that in a calculus-friendly way. Then I'm going to take the derivative with respect to time. So when I take the derivative, it'll need the hook with dt at the bottom. So the derivative of y is 1, but it needs the hook dy by dt. The derivative of x to the half is 1/2 x to the negative a half, but it needs the hook dx by dt. So because we're taking the derivative with respect to time, both x and y need that extra hook. So I'm told that dy by dt is 4. I am told we found the x coordinate to be 4. And I'm looking for this, dx by dt. So let's do a little bit of numbers here, sense. So 4 to the negative a half, what does that mean? Well, 1/2, the exponent means square root. So the square root of 4 is 2. And then the negative exponent, the reciprocal. So it's not 2, but the end with that negative exponent is 1/2. Next, 1/2 times 1/2 is 1/4. And then, how do I undo a quarter? Well, you could divide, but a better way or simpler way would actually be to multiply both sides by 4. So 1/4 times 4, dx by dt is now by itself. And 4 times 4 gives me the answer 16. We do have units, so the answer would be 16 centimeters per second. So at what rate is x moving? So you would write down the x coordinate is moving at a rate of 16 centimeters per second when y equals 2. All right, now a bunch of questions to do with differentiation, continuity, and so on. I'm going to do it right probably on the sheet itself, but you need to do it on your answer document that you're using. All right, they're given a graph here to the right. Is f continuous at x equals 0? And the answer is yes. There is no breaks, no holes, nothing. It is continuous. You wouldn't lift up your pencil there. Is f differentiable at x equals 0? And the answer is no. So why is it not differentiable right there at 0? So the correct answer is the derivative to the left is not equal. So you could say a cusp. But a better answer, a cusp would be like a sharp corner. A better answer would be that the derivative of f at x as x approaches 0 from the left does not equal the derivative of f at x from the right. So the better answer is understanding the derivative on the left does not match the derivative on the right. One is a negative derivative and the other is a positive one as it's approaching 0. That's the kind of answer they're looking for, that you understand. You could do that in words too. The derivative as the function approaches 0 from the left does not equal the derivative as the function approaches 0 from the right. Then you understand why a cusp is bad for derivatives. Hey, there's a graph of x cubed here to the right. Is it continuous there? Yes. Does the derivative exist at 0? And the answer is no. And why? This one's simple. There's a vertical tangent. So what is a vertical tangent would mean that the slope is undefined at 0. And that's what derivative is. So the derivative is undefined because there's a vertical slope right at 0. 22. We'll see if I have room here. It says, is f continuous? So if there's continuity, there's three things that need to happen. So for continuity, first of all, we look at it as a limit. What's the limit as x approaches 0 from the left of f at x? And from the left, that's the top piece. You plug in and you get the answer 1. You look from the right side. And if you plug 0 into the right, you get 1. And then what is the actual function value at 0? So at 0, you plug into the top piece and 1. Do you notice that all three give you the same answer? So the limit approaching from the left, the limit approaching from the right, and that the function value is. All three need to happen. And we say, yes, it is continuous at x equals 0. Now the next question is it differentiable at x equals 0? And if not, why not? So when I look at 0 and look at differentiability, first of all, I need to know it's continuous at 0. Because if it's not continuous at 0, it can't be differentiable. So the next thing I look at then is to take the derivative of both parts. And then the top and the bottom have to match. So the derivative of the top is 2x. There's the prime. That's when x is less than or equal to 0. The derivative on the bottom is 2x plus 1. That's when x is greater than 0. So we have a derivative of the top piece, the derivative of the bottom piece. Now plug in. And what do you notice that when you plug in? That they don't match. So the derivative as x approaches 0 from the left, it equals 0. The derivative as x approaches 0 from the right, the answer is 1. Therefore, is it differentiable? And the answer is no. And you showed why it's no. Number 23. Is it continuous? So what three things do we need to show that it's continuous? So first I need to show the limit. So the limit as x approaches 0 from the left of f at x, what's happening? That's the top piece. That answers 1. The limit as x approaches 0 from the right of f at x. Plug 0 into the bottom piece. That's 2. Then just plug 0 in. In which piece would you plug in? And the answer is 1. So the question is it continuous? Do these three numbers match? And the answer is no. So, and then the question is it differentiable at 0? And again, the answer is no, because it is not continuous. If there is no continuity, you cannot take the derivative at that x value. Number 24. Is it continuous? What do we do? Set up a limit. The limit as x approaches 0 from the left of f at x. So from the left, the answer is 1. The limit as x approaches 0 from the right. Look at the bottom piece. It's positive 1. And then the function value at 1, or at 0, that's the top piece, is 1. Do they all three match? The limit from the left, the limit from the right, and the actual function value. So part A, the answer is yes, because they all three match. Is it differentiable at x equals 0? That way I need to take the derivative. So when I take the derivative here, I get 2x. The bottom, I get negative 2x. And then when I plug in 0, I get the same answer. So it's continuous, and the derivative from the left and the right give you the same answer. So then the answer is yes. And what's the reason it's yes? Because the derivative approaching from the left is equal to 0, and the derivative as x approaches 0 from the right is equal to 0. So they match. All right, 25. Is f continuous at 0? So if I plug 0 in, I get the answer 1. This is a step function. At every integer, it pops up a step. So when I answer that, the answer is no. Because when I plug in 0, you're left with an integer. And at every integer, it's going to pop up a step or down a step. So is it differentiable? No. F at x is not continuous at x equals 0. So because there's no continuity, the derivative can't exist. 26, last one. Without a calculator, find the points where the graph has horizontal tangent. So I'm going to do it right here. So to find horizontal tangents, you take the derivative. That's 3x squared. Subtract 6x. And derivative of 3 is 0. Horizontal tangent means the slope is 0. So we're going to make it equal to 0. And we're going to factor to do this. Take each one, make it equal to 0, and solve it. So the first one gives you the answer 0. The second one gives you the answer 2. So it says find the points. So we got 0 and 2 being the x-coordinates. So if I plug in 0, the answer is 3. If I plug in 2, I get 2 cubed, 2 squared, subtract times negative 3 plus 3. So that's 8. That's 12, 3. I think that's negative 1. Let me just make sure. Yes. So at what points? So 0, 3, and 2, negative 3. Or 2, negative 1, I mean. That's where the horizontal tangent points are. I am so proud of you that you finished your work, you reviewed. I know it's not easy. Sometimes you can press pause and do the work. Sometimes you need to listen to me to support you. All right. Mr. G Math over and out. And until next time.